All right, welcome everyone to Wisens Academy. All right, and then we are looking at Aspen Plus process simulation training. Okay, so basically we are working with Aspen Plus for now. We are done with the Aspen ICES introduction, so right now we are focused on Aspen Plus. And then we did the Aspen Plus introduction, dropped some videos on that last week. So if you haven't done that, go over it again and you proceed. All right, so now we are looking at module 2. We are working with module 2, and basically in the first one we talked about a lot of introductions, explaining the property environment of Aspen Plus, um, explain the simulation environment and all that. Okay, so if you haven't gone over that, if you haven't gone through it, just do that. Then for our students, we did some analysis. All right, so basically you have to go over that as well. All right, okay, so let's move on. So for this module 2, we are looking at unit operations and convergence. All right, so we are going to be working with different operating unit operations, and then we'll be looking at their convergence after we've gotten our results. All right, so we just look at them and then perform some analysis on them. All right, so this is premium for that has been a premium for our students. All right, um so let's move on. So we have a problem statement we are looking at here, and in this problem statement we are looking at this. Okay, so a mixture containing 50% molecular weight, 50% weight of acetone and then 50% weight of water is to be separated. All right, is to be separated into two streams, one enriched in acetone and the other in water. All right, so the separation process consists of extraction of acetone from the water into methyl isobutyl kenton, all right, that's MIBK, which dissolves acetone in but is nearly immiscible with water. All right, so the overall goal of this problem is to separate the feed stream into two streams which have greater than 90% purity of water and acetone respectively. So basically we're going to be using our MIBK to dissolve the acetone to enable us to separate it from the water. All right, so the feed stream of 100 pounds per hour of 50-50 acetone water mixed with a solvent stream of 100 pounds per hour of MIBK. Okay, so after doing that, the three flash separator is added with a temperature of 75 Fahrenheit and the pressure of 50 psi to separate our mixture into two liquid streams, one composed of primarily water and acetone, and one composed of primarily MIBK and acetone. All right, so to go further into this, like I said, you need to take note of your component. All right, so the first component we are using is acetone, the next is water, and MIBK, that's the third one. All right, and basically the best way I love to add my um, components, where I like to find it, is using the CAS number. I feel that's the fastest way to get it. All right, so you just browse it, get your CAS number for any component you're working with, and then you move on. All right, so I'm doing that of acetone first. So acetone is 67641. All right, so why I love using this is that it's straightforward to just get the component I'm looking for, and then I add and go further. All right, the next one is water, which is 773218.5. All right, okay, this is my water. I add a component, and then the last one is MIBK. All right, and that is 108.10.1. All right, so this is it. Okay, add. So having done that, click on next. Now it's going to take me to my method. For this, I'm going to be making use of the sour relish one. So that's basically what I'm going to be using for this. Click on next. Why? Because of we're going to be performing a separation process. We are having vapor with two liquids. All right, that's because of the flash drop that we're using. All right, so this is telling us that we have results available with warning, and then it's saying our free water method should be steam NBS. All right, this is steam table, steam NBS, when the main property method is SRK. All right, so what we just need to do is to go to our method. All right, so under free water, we just change it to this, as steam NBS, right? And then click on next and we run. All right, so you can see that the warning sign is gone and then we have results available. So let's go down to our simulation. Okay, so from here we add the mixer into it because that's the first thing, and then we add our feed, which is the first one, and the second feed, which is for the solvent, and we have the product coming out, which is the solution. And for our separation process, we have the 3-flash separator, and we add that here. Okay, so from this separator, we are supposed to be having the vapor, the first liquid, and the second liquid. Okay, so this thing connects. So, oh, okay. All right, so let's go back. It's connected. We need to connect this to it. All right, so let me straighten out this. Straighten this. Okay, so the first stream we're going to be having here is our feed. Let's call it feed. Second one, we'll call it the solvent. All right, and then this place you just call it solution. Okay, can call this one vapor. Can call this first liquid LIQ, and then call this second LIQ. All right, so straighten this. All right, so from the question, all right, from the question, we have 50-50 water and acetone from inside the feed, and then it's moving at a mass flow of 100 pounds per hour. All right, so let's go to our feed. Okay, so since the temperature wasn't given, we assume it's going to be 25, and then the pressure, we take it as 1 atm since it wasn't given for this stream. Now this is changing to mass flow, and then we have 100 pounds per hour as our feed mass flow rate. On this composition part, I change it to mass fraction. All right, and then I put in 0.5 here and 0.5 for acetone and water. All right, having done that, I can see that my feed is telling me that it's good to go. All right, so the next thing is my solvent. All right, so for my solvent, you still assume 25, and then we have, okay, sorry, I need to go back. I'm supposed to change my screen for this. All right, so let me just quickly go over that again. Um, all right, let me quickly just do that again. All right, so our feed, we assumed it to be 25. We said the pressure is 1 atm, and then we have the mass flow of 100 pounds per hour. All right, that's for the feed. Then the mass fraction we said is 0.5, 0.5. Okay, so moving on to the solvent. Let's close it out from here. Okay, so for my solvent, so we are still taking our temperature to be 25, taking our pressure to be 1. And then for the total flow basis, we have it as mass, but I can actually put it here since I'm just making use of my mass flow. I just have one component in this, so I'm just going to put it 100 here and then change this to pounds per hour. All right, so having done that, let's move on. So the last thing to specify right now, okay, I can just change this to mix mix. That's my mixer. My flash drum is flash. Okay, all right. So, mm, all right. So let's go on. Let's straighten this. All right. So for the flash, it's operating at a temperature of 75 Fahrenheit, and then we have this to be 50 psi. So let's look for psi. That is it here. All right. So with this, we can see that the run button came up for me to use. So basically I've conducted all I need to do. I've added all the specification for this particular process, necessary all the specifications necessary to run this particular simulation for now. So click on run. Okay, it's calculating, generating results. That's and then it says results are available. So basically it has calculated our results for us. So I want to check the separation process here. So I can just go to stream. Here I right click, I click on it, right click, and then go to stream results. All right, so now I can monitor what I have here. Can monitor what we have here, and then let's just go to the mass flow and see what we are having. Okay, so zero vapor. We don't have a vapor stream. Our first liquid is coming at, what do we have more here? We have more of acetone here in the first liquid. So we have more of acetone and MIBK in the first liquid, and in the second one we have majority of the water coming out from it. All right, so this is not the end of the process. All right, this is just part one of this. All right, so we still have more units to be adding to this particular one. So this is more like a build up. So this is the first one, so stay tuned for the continuation. All right, so if you haven't subscribed to the channel, do that now and stay tuned for the next one.